Hi, this is the third video in the series where we're looking at the higher tier paper for the November 2017 paper 2 for Edexcel. Okay, in the previous video we completed through to question number 14 and we're going to start today from question number 15 onwards. I'm going to aim for about half an hour's worth of video. Please do stop, have a go at each of the questions and then compare your solutions, and it should give you about an hour's worth of fairly focused revision. Okay, so let's move on then with question number 15. It says Tracy is going to choose a main course and dessert in a cafe. She can choose from 8 main, 7. Tracy says to work out a number of different ways of choosing a main course, and you have to add. Okay, well you don't actually, you multiply them. So actually no, it's incorrect. She's not correct because you would multiply 8 times 7, so that's going to give her 56 choices. Okay, hopefully that's okay for you. Let's move on then to part B. 12 teams playing a competition. Each team plays the other team exactly once. Okay, that's the important thing with that, they're exactly once. Okay, so work out the total number of games played. Well, you've got each team playing the other team, okay? But you've got to remember that actually it's the same as saying if team A plays B, it's the same as B plays A. Okay, both of those are the same, okay? So therefore we divide by 2, which means then it would be 66 games, okay? Hopefully that's okay for you and you're able to work with that. Let's move on then to question number 16, where we're being asked to solve. Now, this is actually only a 2-mark question, so it's fairly straightforward. I guess you could expand out the brackets, square them, and then make this in some sort of quadratic equation and use the formula, use the quadratic formula. However, you're kind of almost halfway there because this is really completing the square. So what we're doing is we're finding the value of x. Okay, so we've got to get rid of this squared bit here. So I'm going to square root both sides. If I square root the first side, I get x minus 2, so I'm going to square root it. If I square root 3, you've got to remember that the square root of 3 is plus or minus, okay? So the square root of, say, 9 is actually plus 3, which is 3 times 3, or it's negative 3. So negative 3 times negative 3 is still 9, okay? So it's plus or minus when you square root something. Okay, I've got this minus 2 here I need to get rid of, so I'm going to add 2 to both sides. Okay, so I get x equals 2 plus or minus the root of 3. Okay, I need to calculate both of those. The first value of x is going to be 2 plus the root of 3, which is going to equal 3.78, oh no, beg pardon, 3.732. 0.50808, okay, and then I've got 2 minus the root of 3, which is 0.267949. Okay, not particularly relevant, I just wrote it all out because they're looking for the answer to 3 significant figures. So if I look at the first number, the third significant figure is 3. It doesn't change because of the 2, so therefore the first value of x is 3.73, or the second value of x, third significant figure, is 7. Okay, that is going to change because the one after it is a 9, so this is now going to become an 8, so I've got 0.268. Okay, and those are my 2 values of x. Let's move on then to a question 17, which is a histogram question. Histograms are quite popular actually, they do crop up a fair bit, and really they're fairly straightforward because the only thing you need to remember with histograms is the formula frequency density equals frequency divided by class width. Okay, so here we've got the class widths and we've got the frequency, so for each of these we can work out the frequency density. Okay, so the frequency density for the first group is going to be 15 divided by 10, which is 1.5. For the second group it's going to be 30 divided by 5, so that's going to be 6. The third group, it's going to be 51, again divided by 5, so that's going to be 10.2. 36 divided by 5 is 7.2, and 18 divided by, what's that, 15? Something like that. Yep. Yeah, 15, and that's going to be 1.2. Okay, so what we've got there is the values of frequency density that we're going to plot on the y-axis. So always with histograms, the frequency density is on the vertical axis. Okay, and then it's really just a matter of figuring out how I'm going to take these values and put them into the y-axis in a way that kind of looks nice, really. Now you'll see the maximum value is 10.2. Okay, so what I'm going to do is I'm going to have a look at this, and I've figured out that actually I can just write 2, 4, 6, 8, 10 and 12. So 10.2 is going to be around here somewhere. So actually my maximum value is going to be up here. Okay, and then I can have a look at the class widths value, which is on the x-axis, which is going to be the heights. Okay, now again, it's just sometimes you've got to be just a little bit careful. I need to have somewhere between 140 to 180. So if I start here, I've got 140, I can say 150, 160, 170 and 180. So it means that my final class width is going to finish at that point there. Okay, I also might want to just add in the units as well while I think about it. Okay, so now we've got our grid set up, so we can actually start to draw in our histogram. So the first values is that I've got a frequency density of 1.5, and I've also got a class width of 140 to 150. So 140 to 150 is here, and 1.5 is about there. Okay, so that's going to be my first value. Okay, now I'm not using a ruler for this, so hopefully it's going to turn out okay. My second one is a frequency density of 6, and I've got a class width of 5. So actually it's going to go to here. So I've got 6, okay, something like that. Okay, and that's going to be my second block. My third block is the one where it goes to 10.2 at the very, very top there. And again, it's got a class width of 5. Okay, so that's okay. It's going to come up something like that. Okay, like that. All right. So my third one is class width of 5 again, and it's 7.2 this time. So 7 is in the middle, 7.2 is going to be there, and again that's 5. And then my final one is going to be the difference between 165 and 180, and a frequency density of 1.2, so it's going to be around here. Okay, and actually that's a fairly reasonable histogram. Obviously you're going to use a ruler, hopefully make it a little bit make it look a little bit neater than mine, but hopefully it'll give you some idea of what it should look like on your solution. Okay, so part B of this question, it says work out an estimate for the fraction of the students who have a height between 150 and 170. Well, we do know there are 150 students. Okay, so there's 150. So what we're going to try and figure out is something out of 150. Okay, so what we've got then is that we know between 150 to 155 there are actually 30 students. So if we go back to the information we got in our grid, between 150 and 155 there are 30 students. So actually we can use quite a bit of this information to be able to help us through. Now I won't keep moving the bits of paper, but hopefully you should be able to see that most times I'm going to be referring to this grid at the top here. So let's have a look at what we've got. Okay, so between 150 and 155 we've got 30 students. Okay, between 155 and 160 we've got 51 students, and again I've got that information from the grid itself. Between 160 and 165, I've got another 36 students. And then 165 to 170, okay, this is where it's slightly difficult because we're looking at the 165 to 170. Now, hopefully you'll be able to see on the diagram that that's actually 1/3 of this block. And in this block, there are actually 18 students overall. So 1/3 of it would mean that the height between 165 and 170 is actually going to be 1/3 of 18, which is 6 students. So therefore, I now know that the total amount of students with a height of between 150 and 170 is 123. Okay, and if you remember, we said that there were 150 students altogether, so therefore we've got a fraction of students, 123 out of 150 students, and that would answer this particular question. Okay, so we're 11 minutes into the video. I'm going to move on then to question number 18. Okay, and question number 18 is just one of those questions that you've got to kind of, it's only worth 1 mark, but it just takes a little bit of time to kind of figure out what it is that they're talking about. So at a time t equals 0 hours, a tank is full of water. Okay, so we've got this water in this tank and then it's basically leaking away. At the end of each hour, there is 2% less water in the tank than at the start of the hour. Okay, so in other words, what we're saying is that there is 98% of the water left in the tank. Okay, 98% left at the end of each hour. Okay. Then it says the volume of water in litres in the tank in the time is this. And it looks awfully complicated, but really what it's saying is that we're starting with 2,000 litres, okay? And then every hour, so an increase of an hour, there's 98% of the value left, okay? So it means then the value of K is actually just simply 0.98, okay? And that's actually the answer to this question. So a lot of working through, or a lot of kind of understanding of what they're talking about, a lot of words in there, but really they're just asking you to explain the formula. Okay, let's have a look then at question number 19, which is a little bit more challenging because we need to maybe visualize what's going on with this particular question. We are coming sort of towards the end of the paper here, so questions are going to get a little bit more difficult as we work through. We've actually only got 23 questions on this paper, so we're probably going to stop the video fairly soon and then do the final 2 questions in a future video. Okay, so a triangle has vertices, in other words, has corners of P, Q and R. The coordinates of P are that, Q is that, R is that. Alright, so what I'm going to do is, firstly, I'm just going to draw a little diagram of what that actually looks like. So, I've got my axes there, okay. So, if we look at P, well, P is -3, -6. So I'm going to put P somewhere down here. So this is P, okay, and the value of P is -3, -6. I'd always recommend that you have a go at drawing these sorts of things, just so you can see what's actually going on. Okay, Q is 1,4, so Q is somewhere up here. It doesn't have to be brilliantly accurate, okay, but, oops, sorry, Q is 1,4, okay, but at least it'll give you some sense. And then R is going to be 5 -2, so 5 -2 is R, 5 -2. Okay, so what we've got actually now is a very neat kind of triangle, okay, that looks something like that. Okay, hopefully that's okay for you and you would have got something fairly similar. Okay, then it says M is the midpoint of PQ. So here's M, there it is. Okay, this is M, okay, and this is the midpoint. Okay, now at the moment we don't know those coordinates, but it's telling us that M is the midpoint. N is the midpoint of QR. Okay, so N, which is here, is the midpoint of QR. Okay, right, so then it says prove that MN is parallel to PR. Okay, so what they basically mean in all of this is that the gradient of that is the same as the gradient of that. So the gradient here is the same as the gradient there, and that's basically what they're asking us to prove. Okay, so in order to do that, let's have a look and see if we can find out the coordinates of M and the coordinates of M. Okay, well, the coordinates of M, let's have a look at that. So the x coordinate is going to be -3 and 1 divided by 2. Okay, so the midpoint or x value is going to be -3 plus 1 divided by 2. These are the x values. Okay, the y value is going to be -6 plus 4, again divided by 2. -6 plus 4 divided by 2. Okay, so the coordinates of M are going to be -3 plus 1 is -2, divided by 2 is going to be -1, and then -6 plus 4 is -2, divided by 2 is also -1. So M, the coordinate, is going to be -1, -1. Okay, right, let's do exactly the same then for N. Okay, so if we look at N, hopefully you can see this okay. I'm going to do exactly the same exercise where I'm going to say that the N value is going to be the difference between 5, the x, and 1, and then divide by 2. Okay, so N is going to be 1 plus 5 over 2. And then the y value is the difference in the y coordinates, which is 4 plus -2, all divided by 2. Okay, so that's going to give me an n value of 1 plus 5 is 6, divided by 2 is 3. Okay, and 4 minus 2, remember a plus and a minus together become a minus, so 4 minus 2 is 2, divided by 2 is 1. Okay, so now I have the coordinates for M and for N. Now it allows me then to work out the gradients, because the gradient is just basically the difference in y divided by the difference in x. Okay, so hopefully I'll be able to sort of squeeze this onto here for you. Okay, so the gradient is, let's look at firstly for Mn. And that's going to be equal to the difference in y divided by the difference in x. Okay, so if I have a look at the difference in y between M and N, if we look at y, we got -1 to 1 is a difference of 2. And the difference in x is -1 to 3, which is a difference of 4. So therefore, the gradient of Mn is a half. Okay, now in order for PR to be parallel, it has to be the same gradient. So let's look at the gradient of PR. Okay, well again, difference in y divided by difference in x. So let's have a look at the difference in y. It's going to be the difference between -6 and -2. Well, that's a difference of 4. Okay, the difference in x is going to be a difference between -3 and 5. So there's going to be 8 jumps between -3 and 5, which is going to be there. So that means then that PR has a gradient of a half. Okay, so therefore both PR and Mn are parallel. And if you want to put same gradients, that's perfectly fine. Okay, and that would answer that particular question. I hope that's been useful to you. I think what we'll do is we'll carry on and we'll just do question number 20. And then question number 20, we'll stop the video, have a bit of a break, Okay, and then we'll move on to the final part of this particular paper. Okay, so moving on to then question number 20, where we're asking us to calculate the area of the shaded region. Okay, so the area of the shaded region is basically made up of effectively a shape like that, okay, minus this particular shape here, which is this sector. Okay, so the easiest thing probably to start off with is actually to work out the area of the sector, okay, and then I'm going to work out the area of the overall shape. Okay, so the area of the sector first. Now, I will be moving this up and down the screen a little bit, but hopefully you'll be able to see that what I'm looking at is area of sector OAC. Okay, well, that's going to be a fraction out of 360 degrees, and we're told that it's 120. So if you can imagine, this is a full circle with a radius of 10. What we're looking at is 120 out of 360 degrees multiplied by the area of a full circle, which is going to be pi r squared. Now, r in this particular case is 10 squared. Okay, so the area of sector OAC is 100 over 3 pi. And if you want to pop that in a calculator and write it out as 104.719, so on, that's perfectly fine for you if you like. I'm going to leave it as 100 over 3 pi. Okay, so the next little bit is I need to work out the overall area of this particular quadrilateral, this four-sided shape. Now, what I do know is that these are right angles. Now, the reason I know they're right angles is it tells me that it's a tangent to the circle. So BA is a tangent to this circle. Now, because it's a tangent always meets the circle at 90 degrees. So actually what we've got here is two right angle triangles. Okay, and we can use SOHCAHTOA to be able to work out the height of this particular triangle. What I'll do is I'll draw it so you can actually see it. Okay, so if I work out this, I can draw it as something like, I'll try to sort of copy it. I've got this triangle. I think what I'll do is I'll do the right hand side one. Okay, I think I'll copy this one here because I want you to get this height. Okay, so I'll copy this. Okay, so I've got a 90 degrees. Okay, I also know that this is going to be 10. The reason I know that's 10 is because that's actually going to be the same as the radius of the circle. I also know, if I go back to it, that this part of it is actually 60 degrees. Okay, so I know it's a right angle triangle with this length at 10 and this part of it is going to be 60 degrees. Okay, so this is 60 degrees in here. So I've got enough information for me to be able to work out this. Okay, the hypotenuse of the triangle, and the hypotenuse of the triangle is actually going to be the height of this overall shape here. Okay, hopefully that's all right for you. Okay, so let's have a look then at what I need. Okay, so if I write SOHCAHTOA, okay, now the ratio I'm going to use is going to be cosine. Now the reason I'm going to use that is because the opposite I don't know. I do know, or I'm interested in the hypotenuse, but and I also know the adjacent, so therefore I can use the cosine ratio. So I can say the cos of 60 degrees equals the adjacent, which is 10, divided by the hypotenuse, which I don't know. So if I want to figure out the value of the hypotenuse, I've got 10 divided by the cosine of 60 degrees, which is going to give me 20, actually exactly 20. So what it's telling me is that this length along here, which is this height along here, is actually 20 centimetres or 20 metres. Okay. Right, so I've got now a little bit more information. Now the other formula that you'll need is I can work out the area of a triangle using a half AB sine C. Okay, so what we've done is we've got this triangle. Now I know we've got two of them, but we know that that actually is A and this is B. So I'm going to sort of redraw it just so that you can kind of see it for yourself. So now I know a fair bit about these two triangles. This is 20, this is 10, and this is 60 degrees. Now if I know that, it allows me then to work out the area using this formula. So I can just plug those numbers in, and I've got a half times A, which is 20, times B, which is 10, times C, which is the sine of 60 degrees. Okay, pop those into my calculator, and I get 50 root 3. Okay, now again, you can, if you want to have the decimal equivalent, that's going to be 86.6025. Okay, there are actually two of these triangles side by side. Again, if we go back to the diagram, I've got this triangle which we've been working on, but we've also got this triangle which is exactly the same. Okay, so if it's exactly the same, it means that we can just multiply this by 2, and that's going to give me then 173.2050808. Okay, your calculator might be slightly different, but hopefully that'll give you the kind of calculation that we need. Okay, so what we've got then is the area of the shaded region. Okay, well, if you remember, we said originally the total area was this. This is right at the very top of the screen here. Okay, and we've worked out the area of the two triangles. So if we take one away from the other, we're going to get the area of the shaded region. So that's going to be 104.719 ... minus I'm so sorry, it's going to be 173.205 0808. Take away the area of the sector of the circle, which is this, okay, and that's going to give me 68.4853, and that will be the area of the shaded piece. Okay, I hope that's been okay for you. There is quite a lot of work to do on that particular question, but it should give you some idea of the kind of system that we can use to be able to work that out to 3 significant figures of 68.5 meters squared. Okay, please do add a comment in the section below if you're not sure about anything. Have a look also on the channel playlists, and there are quite a few other examples of other sort of questions that are similar to this, or certainly there's other walkthroughs on exam papers as well. We're going to complete there, and we're going to start then from question number 21 in the next video, and I look forward to seeing you then.